All right, so we are back and ready for math. Today we're going to be doing lesson 6.5 and this one. And if you're on the accelerated daily schedule, then you'll also have 6.6 as well. But this will be just lesson 6.5. So in your book, if you'll look on page 101, I'm sorry, no, not 101. I have the wrong book. No, that's where the worksheet's at. As I was saying, I'm sorry, I had the wrong page. We're going to be in your book on page 148, section 6.5. We're at the dividing fractions. All right, so let's kind of review through here. We're fixing to be at the end of our chapter. So ready for some more fraction fun? Well, ready or not, today's topic is dividing fractions. I'm at the top of page 148. Aww. You may have already learned to invert and multiply. But did you realize there are other methods we could use to divide fractions too? As we did with multiplying fractions, we're going to start by taking a look at what we're really doing when we divide fractions. As we do, we're going to discover once again that the rule we follow is just a way of automating the process of describing a consistency God created and sustains. All right, so this section we're going to understand the why behind it. As we saw in section 3.4, division means separating into two or more parts, areas, or groups. We also saw that because of God's faithfulness in holding all things together, division is consistent enough for us to memorize answers and divide using algorithms or step-by-step methods. Before we jump to how to divide fractions, though, let's explore the concept of dividing fractional quantities. Although fractional division can sometimes be a little more abstract, it too ultimately works because of God's faithfulness. While we typically think of division as dividing a quantity into smaller parts, it's also the process of finding out how many times one number is contained in another. When we divide 10 by 2, our answer 5 tells us both what would happen if we took 10 and divided it into two piles, also how many times 2 is contained inside 10, which would be 5 times. There's your little picture there. Kind of gives you the idea of what division tells us. Likewise, when we divide 6 by 2, the answer is 3. That not only tells us how many we will have if we divide 6 into 2, but also how many times 2 is contained in 6. There's your picture of that. The same holds true when dividing a fractional amount by a whole amount. We can look at the division as what would happen if we divided and as how many times one number is contained in another. All right, let's look at page 149. So you have half divided by 2, which equals 1/4. 1/4 is the result of splitting half into two portions. And the number of times 2 is contained in half, only 1 out of 4 parts of 2, that is 1/4, is contained in a half. All right, here's 1/2 divided by 2 equals 3/4. 3/4 is the result of splitting 1 1/2 into two portions. The number of times 2 is contained in 1 1/2. 3 out of 4 parts, that is 3/4 of 2. That's just up at the top. That's a little confusing, but it's kind of showing you the two different things that division means. So it proves extremely helpful for understanding dividing by a fraction if you think of dividing fractions as figuring out how many times one number is contained in another. All right, so we're right here kind of towards the bottom of page 149. 2 divided by 1/2 equals 4. Okay, so there shows your cupcakes. Half is contained in 2 a total number of 4 times. Okay, 1/2 divided by 1/4 equals 2. And there you go. It shows you 1/4 is divided into half twice. Okay, now let's get to the rule. So how do we reduce division by fractions to something we can do mechanically without having to draw diagrams? You've probably been taught to invert and multiply. In other words, flip the second number upside down. Like we learned in the other section, get the reciprocal, the second fraction when you multiply. Like you take 1/2 and divide it by 1/4. Well, I was taught you change it to multiplication and you take the reciprocal of that second fraction. So really in what it's saying is you would have 1/2 times 4/1. which then if you just multiply it across, you get 4 over 2, which equals 2. But why does that rule work? Let's step back for a minute and examine dividing fractions more carefully. Turn the page. Okay, so division means division. When we multiply both our numerators and our denominators to get our answer. We can do the same thing in division if we have a problem where the numerators and denominators divide evenly. For instance, 8/6 divided by 2/3. Well, 8 divided by 2 that can go down to 4. 2 divides into 8 evenly is what I'm trying to say. And 3 can divide into 6 evenly. So you get 4 halves, which equals 2. There's just one problem. Sometimes we run into fractions that don't divide so easily, like our original example, 1/2 divided by 1/4. So if you follow the same process as before, we would end up with a fraction in the denominator. So 1/2 divided by 1/4, and this is if you're dividing, just across. So you'd end up with 1/2 or 1 over 2/4. We still haven't found a very useful answer. But remember how we learned that we can multiply any fraction by a fraction worth 1 without changing its value. Well, even though 1 over 2/4 has an additional fraction in the denominator, the whole thing is still a fraction. So we could multiply it by a fraction worth 1 without changing its value. Now, if we multiply the fraction by 4 over 2, which is the inverse of the denominator, the reciprocal. Remember, you flip it upside down. The denominator will cancel it out, multiplying by a fraction worth 1. So here it shows you 1 over 2/4 times, multiply both the top and the bottom by the reciprocal of the bottom, and basically you're going to end up coming out with 2, because 4 halves, or 4 over 2, is 2. Over 1, then you'll have 2 over 1, which that equals 2. Okay, so that's kind of the long way around it. It's just kind of showing you the y and all that kind of stuff. So don't worry if you didn't follow the whole process we went through above. Just notice how when we multiplied by a fraction worth 1, the fraction in the denominator canceled out, basically leaving us with 1 times 4 over 2. Okay. So let's look on page 151, and it says the rule for dividing by fractions by inverting the divisor and multiplying is just a shortcut to jump to the end result and save ourselves a lot of work. It makes it possible for us to quickly find an answer without having to think it through each time. So basically what I just told you, where it says division means division, where they divided across and they did this and they had this fraction on top of that, that was just a long way around of what we're actually going to do. But it wanted to show you the why that works. Okay, so you see the big gray box here on page 151. It says another way to divide fractions. The invert and multiply method for dividing fractions is just one way to figure out on paper what happens in real life when we divide fractions. Let's take a quick look at another method of solving fractional division. Here's an example. The same one, 1/2 divided by 1/4. We could divide by first renaming the fractions until our denominators are equal, as we did for addition and subtraction. If our denominators are equal, then we divide the denominator. Then when we divide the denominator, it'll equal 1, as any number divided by itself equals 1. So if you're going to rename half, we'll rename that to 2/4, and we'll keep 1/4 the same because we just had to get common denominators on the bottom. So we might as well keep 4 and just change 1/2 to 2/4, so that gives us 2/4 divided by 1/4. Divide the numerators and the denominators. 2 divided by 1 and 4 divided by 4. You come up with 2 over 1, which 2 over 1 equals 2. So in other words, to divide fractions, we could rewrite the fractions so they both have the same denominators, and then divide the numerators. While the invert and multiply method is faster, remember it's just one way. Helps us work with the consistency all around us, that consistency that God sustains. All right, we have to look at one more thing. Then I'll show you a couple of things up here to kind of get you started. Okay, so any guesses on how to divide whole or mixed numbers? convert them to improper fractions, and then follow any one of those methods that we just did. Okay, so we're not going to read the keeping perspective today. So what we're going to do is we're going to look at worksheet 6.5 in your other book where the worksheets are. It does say that you can use the calculator on this page only where you see it. So it looks like on number 6 on the back you can use it, and that's it. Okay, so let's go ahead and look. Whoop, I messed up my page. Go ahead and look at the page. All right, so I'm going to go ahead and basically I'm going to show you what I just read to you. It's been several days since I've put lessons together, so I can't really remember what we did in the last lesson in 6.4, but I know that we learned how to, let me make this a little bigger, it's easier to write with. I know we learned how to invert fractions. If you have 2/4, well, to get the reciprocal would be to flip this upside down. That's all you do. It's called the reciprocal. You just flip it upside down. Some people call it inverting, like you invert it. Okay, that's all it is. You can take any fraction and do it. Let's do 1/3. To get the reciprocal, you flip it upside down. You invert it. That's all you do. Okay? All right. Let us now, we're going to go ahead and do some division. If you'll look at number 1 on worksheet 6.5, 1A gives us 3/4 divided by 2/3. Now, before we do it, I want to remind you of this. When you add or subtract fractions, remember these denominators have to be the same. If they're not the same, then you have to get equivalent. You have to turn each one of them into equivalent fractions that have the same denominators. Okay? That's with addition and subtraction. Multiplication's easy peasy. You just go whoop, whoop, bam, you're done. Simplify that fraction. Or remember the shortcut I showed you where you can cross out if you're multiplying. So that way your answer is already simplified. Okay, division is all it is multiplication. So basically what you're going to do is you're going to rewrite the problem, changing it to multiplication and taking the reciprocal of this. Okay, now all that stuff that I read to you in the book that you followed along with me in section 6.5, all that stuff that we talked about was showing you why we do this. So if that's just anything important to you, you can go back and read it. Otherwise, that's all you do. And then you multiply across and simplify. Now, let's see if our shortcut works. So 3 and 2, they have nothing in common, so we can't cross these out. 4 and 3 have nothing, and you can't simplify those down. So that means the answer we get will already be simplified. So 3 times 3 then would be 9. And this is 8. But since that's improper, we need to change it to a mixed number. Remember, we just say 8 goes into 9 one whole time with 1/8 left over. That's all you do. Easy peasy. Same thing as multiplication. I mean, it is multiplication. All you have to do is change it to multiplication and then get the reciprocal of that second number. All right, so let's look at B. B is just written differently. It's written like this, 1/2 divided by 4/7, which I'm sorry, but that just kind of looks silly to me. Sorry, I'm having my afternoon cup of coffee. Basically, it's written like this. They just did it that way just to show you that it can be. Okay? Okay. Only thing you do is you have to say 1/2. This one stays the same. Change it to multiplication. Take the reciprocal of this one. Multiply across. And then simplify this if it needs to be. 7/8 is already simplified. There's nothing to do. That's your answer. That's all you do. All right. So you're going to finish. Now I want you to take a look then at letter E down there at the bottom. It's 1E. They're trying to fool you, I think. It says 9/8 divided by 2. Well, remember that actually a whole number is over 1. It's just kind of like it's invisible. It's just not there. But that's basically all it is. It's 9/8 times, then you'll invert this, 1/2. Then you multiply across. All you do. Okay. So look down at the bottom, right above number 2. There's a note. It says, remember these word problems are designed to mimic real-life settings. You may have to use different tools than those we covered today. Be sure to check your work and make sure the answer makes sense. All right, so you're just going to read. I'm not going to grade this page. I want you to just read through these problems. These are just normal, everyday problems. Just think them through. Do a little step at a time. Use a whole page of paper if you have to. It does not matter. And then on the back, number 6, you can use, you're just going to explore that fraction 180 over 650 minus 13 over 130. Now notice that is a subtraction problem, which means you're going to have to change those denominators. Now I'm just going to kind of give you a heads up on that. So you're going to, now I don't care how you write it, but the way that my teacher taught me how to write it just made way more sense to me. And it was easier because it just made me see things more easily. 13 over 130 is to write it this way because now you're going to have to change these so that they have common denominators. So you're going to have, that's why you can use the calculator. Figure out what these have in common that they both can divide into and put that number here. It has to be common denominators. Okay, and whatever you do down here, you got to do up here. Down here, you got to do up here. Okay, like I said, I'm not going to grade this page, but I want to see what you can remember of it because we're going to be doing some review, I think, here on the next lesson or two. Okay, that is all of this lesson.